We can predict physical properties by looking at the periodic table and the properties of the elements in there. This is not something we do a lot of, but I think it points out the usefulness of the periodic table. So here is an example. Here are some elements: lithium, sodium, potassium, rubidium, and cesium. These are all in which group of the periodic table? They're in group 1A. And what's the name of that group? The alkali metals. So these are all alkali metals. There we go. And francium is Fr. Francium's right at the bottom of that list, right? But it's not on this table. We can predict the properties of francium by looking at the properties of the other elements in that group. Here's the atomic radius. We see that it is increasing as we go down, because what we just learned is when we go up, it decreases. So what could we say about the atomic radius of francium? It's greater than 0.266, right? So its radius is greater than 0.266 nanometers. What could we say about the density? What's the pattern here? It's greater than 1.87. What about the melting point? It's going to be less than this, right? Because as we're going here, they're getting smaller. So melting point, less than 28 degrees Celsius. What about the atomic mass? Greater than this, right? So mass greater than that. So predict the missing value for each physical property listed below. So here we've got platinum, and we're given nickel and palladium and their atomic radii. So here the question is actually wanting us to put a number to this. And so what we can do, because nickel and palladium and platinum are in the same group in the periodic table, they're all transition elements, we can look at the difference between 0.125 and 0.138 and say, well, if there's that jump between those two, then there's probably a similar jump to platinum. The difference there is 0.013. So going from here to here was plus 0.013. So then we'll estimate that it's going to increase by the same amount. So we'll take and add that to 0.138. That's not what I wanted to do. And we're going to estimate that this will be 0.151 nanometers. Does that make sense? Here we've got the density of nickel and the density of platinum. We're looking for the density of the one in the middle. Well, it's probably about halfway. So we can average those. 8.91 plus 21.5. I don't know why it keeps doing that. And then divide by 2. And that predicts a density of about 15.2 grams per cubic centimeter. How would we predict the melting point? What's the change from 1772 to 1554? Oh, I did that math wrong. I came up with 600. That's screw up number 1. Well, no, that's actually screw up number 3 for today. I already forgot 2 things. Yeah, it's 218. So it's going down 218. So then we'll estimate that the next one is 218 less. And say, well, that's probably 1336. Any questions? We can also predict chemical properties from the periodic table. And this is something we use a little bit more often. What we find is that members of a family, remember that's another word for group, a group, also have similar chemical properties. And then, I think of my children. I have 6 children, 5 boys and 1 girl. And people laugh at how similar they are because they look like they were made with cookie cutters. Bang, bang, bang. Oh, yeah, that's a Kawagoa. It's just obvious. But aside from the physical resemblance to each other, they have some personality or chemical similarities as well. They all like to play football. They're pretty good in school. They're friendly. They seem, the older ones all play guitar. Did we force that upon them? No. They're seeming to like chemistry of all things. I've got one who wants to get his PhD in chemistry. He's getting his bachelor's degree. He's a senior this year. I've got another one who's majoring in chemistry. And the next one is showing a strong inclination to go in the same direction. Family similarities, okay? Families of elements have similar characteristics as well. So if we look at the alkali metals, that's group 1A, that first column. Oh, there's a typo. That's supposed to be a subscript 2. I was in a hurry, apparently. M2O. All of these guys have the same relationship with oxygen. 2 lithium atoms to 1 oxygen atom. 2 sodium atoms to 1 oxygen atom. This forms a pattern. So we can use that to predict formulas for other compounds. If the formula for the chloride of calcium is CaCl2, what's the formula for the chloride of barium? Well, look at the periodic table. Barium and calcium are in group 2A. They're in the same family. So if calcium does CaCl2, what does barium do? BaCl2. Okay, so you may run into some questions like that.